From around 2010 onwards, a global epidemic was detected that was as destructive as it was unexpected. No virus nor bacteria was at the origin of it, and yet the threat is more than real.
In some parts of the world, there is a massive epidemic of myopia. Myopia is not just a simple problem of getting glasses. This is one of the top causes of blindness.
83% of 20-year-olds in Singapore are myopic.
即使是我们在医院里面的这个最后端的防线，即使你是全世界最好的眼科医师。
Asia may be bearing the brunt of the problem, but the rest of the world is not far behind.
In Europe, that figure isn't as great. It is rising, and with every decade of birth, we're seeing more and more myopia. So it is a war that we need to work at.
Across the world, scientists are engaged in a race against time. What is the cause of this epidemic? And more importantly, can it be overcome before our children all become nearsighted? We've come to eastern China, where the epicenter of the myopia epidemic is to be found. This is Wenzhou, population of 10 million, 450 kilometers south of Shanghai. The situation here is very worrying. This is a vast specialist eye hospital, which treats 500,000 patients every year.
我们实际上病人呢，就是高峰期会非常明显哦，特别是在比如说平时的周末啊，或者是寒假、暑假的时候，我们一天最多的门诊量超过2000多病人，所以就是到时候就是绝大部分这部分人群呢，都是以学生为主的，就是儿童、青少年这一块特别多的一些近视的人群。所有的医生实际上都是在加班来帮助这些小朋友去解决近视的问题，所以如果说整个近视越来越多的人群，然后会出现越来越多的问题，将来实际上这一块的医疗的负担，包括社会的经济负担，实际上都是非常沉重的。
The serious nature of the situation has only been recognized recently. In 2012, a scientific article published in The Lancet started alarm bells ringing. The author was Ian Morgan, an Australian biologist. He spends several months a year in China to try and get to the root of the problem.
So what would you be looking for in these repeated examinations? Changes in the retina? Would you use OCT, for example?
We can see that this patient has the eyeball nasal distorted. So I think the optic nerve will be restricted.
The Chinese population is expected to peak at around 1.4 billion and then slowly decline after that. On figures that we already have available, we can project that something like 1.2 billion of those people will be myopic, and of them, perhaps 200 to 300 million people will be highly myopic. Not all of them will be visually impaired or blind. But nevertheless, dealing with the problem, ophthalmic and optometric services are going to collapse under the strain.
The developed countries in Asia are taking the full force of the epidemic. Between 80 to 90% of young people suffer from myopia. And there's one thing researchers are now sure of. Myopia is gaining ground amongst the under-25s everywhere. In Europe too, doctors are increasingly on the lookout for myopia. A research program called iShare measures myopia in young people, like here, for example, at the University Hospital of Bordeaux. Cécile Delcourt, epidemiologist at INSERM, the Biomedical French Research Institute, helped organise this huge survey. 60,000 young people were examined and the results are worrying.
Est-ce que vous avez un handicap à signaler, par exemple visuel, auditif ou moteur?
Oui, j'ai un handicap visuel. Je suis myope depuis 4-5 ans à peu près.
Ce qu'a montré notre étude publiée l'année dernière, c'est qu'environ presque la moitié des jeunes Européens sont désormais myopes. Donc on est à 47% des gens âgés de 25 à 29 ans.
At the beginning of the study, researchers focused on those illnesses which cause significant visual defects, such as glaucoma and cataracts.
Donc c'est vrai qu'on a un peu laissé de côté la myopie et finalement, sûrement à tort, je pense qu'on peut parler d'épidémie, alors surtout en Asie où vraiment là les taux ont augmenté dans des proportions très impressionnantes. Chez nous, il y a une augmentation qui n'est pas négligeable et donc effectivement il faut se poser la question de comment on peut contrer ce phénomène.
Je vais prendre plusieurs mesures.
How does myopia come about? The human eye can distinguish shapes and colours thanks to light. Light rays penetrate the cornea and then the pupil. Then the eye's lens retracts and enables a clear but reversed image to form on the retina, at the back of the eye. This image is transmitted by the optic nerve to the brain, which processes it and restores it the right way up. In the case of myopia, the following happens. The eyeball loses its roundness and lengthens irreversibly. Having a long eyeball is a deformity which causes myopia, and in turn leads to blurry vision. When someone who is myopic looks at an object in the distance, a sharp image is no longer formed on the retina, but in front of it, since this part of the eye is further away than normal. Therefore, the image that the retina transmits to the brain is a blurred image. When myopia is severe, everything is blurred. Objects and even faces are difficult to distinguish. Everyday life is impossible without corrective lenses or glasses. And sometimes the condition is so severe that it can lead to acute illnesses or even total blindness.
Regardez bien le point vert. On va commencer le soulèvement du volet cornéen.
Dr. Damien Gatinel is the director of one of France's largest eye hospitals, the Fondation Rothschild. He is very concerned about the rise in cases of severe myopia.
Il y a un réel risque de perdre la vision à cause de la myopie. L'œil myope étant un œil plus long, cette augmentation rapide de la surface du globe se fait sans que la rétine puisse elle-même grandir. Donc la rétine, c'est un tissu qui a une certaine dimension et qui va, quand l'augmentation de la surface à tapisser devient trop importante, se déchirer véritablement, et un peu comme un tissu qui finirait par se déchirer. Et à ce stade, on peut là aussi avoir une baisse de la vision quand la déchirure de ce tissu intervient, encore une fois, au niveau de la zone centrale, qui est la plus précieuse pour notre vision, puisque c'est la seule zone du champ visuel où on voit les détails.
In the event of severe myopia, the risk of disability is therefore very high. The people most affected are found in Eastern Asia, in particular in Singapore. Out of 5 million inhabitants, 2 million of them suffer from myopia. It's an absolute catastrophe. Ahmad Mazliati was born and grew up here. Like many others suffering from severe myopia, her life has always been difficult.
Kalau saya dari primary, saya tak pakai cermin mata, bapa saya kurang bantuan. Saya tengok tu blackboard dekat sekali. Paling depan sekali saya. Tapi teacher a bit move depan lagi sikit pun saya tak nampak. Last kali dia cakap duduk in front near the blackboard. That one also I cannot see. Actually, this one also doctor asked me change the degree because on my degree not so good. You cannot see. I say I don't want lah. I can see people, it's okay lah. I say like that because I study can I change? I not study for what to change. Because my salary also not so many. That's right.
In all, 500,000 people in Singapore suffer from severe myopia. That's 1 in 10 of the population.
So it's, I think, yes, more about would be great.
Professor Sang Mei Saw is an epidemiologist and has noticed the situation getting worse and worse every year.
We have adults 40 to 50 years in Singapore with myopia between -10 to -15, and some of them have very extreme myopia. If we look at their visual impairment, some of them have visually disabling disease, and many of them, age 40 to 50, are still working. So some of their jobs require good vision. It'll be very difficult to be very productive at work if vision is affecting their work. And some of them, maybe even if they are retired, it may affect their activities of daily living.
The scientific community is now starting to take action to combat this threat which hangs over the whole world. To put a stop to the epidemic, it was important to work out where to start and what the causes might be. The first line of research that the scientists explored was genetics. Is myopia passed on to us by our parents? Is it in our genes? Professor Chris Hammond, genetic specialist at King's College London, heads one of the leading teams in this area. In 2010, the team identified for the first time a gene associated with myopia as a result of a study of tens of thousands of people.
Hi Sarah. Hello Ruth, nice to meet you. Thanks both so much for helping us with our twin research and coming to have your eyes tested with Diana. We're very grateful, and we've made so many advances, particularly in short sight. You're short-sighted, both of you, and I am too. And so the work we've done here with the twins has been really helpful in working with our collaborators across the world to try and find out why some of us become short-sighted, and maybe in the future work out why we can stop people becoming short-sighted. But
so exactly the same with the opposite.
What we found is one region on the genome, on chromosome 15, which is in a gene called RAS-GRF1, but what it showed is that that gene is associated with myopia. And at the same time, our collaborators in the Netherlands found a single gene too on chromosome 15 as well.
But just when they thought they had found the gene responsible for the onset of myopia, more than 100 other genes were subsequently identified as being equally to blame. For the geneticists, it's impossible to know which ones are the most significant.
So it's kind of not one gene that causes a family to be myopic. The analogy I give, it's like being handed a deck of cards. Clearly, we get half our cards, our genes from from one parent, and half our genes from the other parent. And so clearly, if you've got two parents who already have high cards, you're much more likely to have high cards and make you more likely to be myopic.
Genes evolve over thousands of years in humans. But this myopia epidemic has only taken a few generations to appear. Are scientists on the wrong track, putting the blame on the genetic theory with all the hundreds of genes involved? The heart of the epidemic can be found 15,000 kilometers away, in Canton, South China. In these ultra-modern labs at the center of ophthalmic research, geneticists have come to the same conclusion.
我们一个双生子和他父母的一个近视的一个父母的一个屈光度的分布。那么从这张图我们可以看到呢，往近视父母的一个屈光度，它的一个是接近于平均的屈光度接近于0，是比较接近的。那么对于他们的双生子来进一步进展，我们可以看到一个很明显的一个往近视方向的一个变化。亲代和子代的它的基因值不会发生明显的变化，那么导致这种变化的趋势的最主要原因是由于环境因素导致了这种近视的一种往 发现呢，遗传因素只解释了近视的2%到3%的变异。
In the face of these disappointing results, researchers wondered whether there wasn't at least a genetic predisposition for myopia in Asian populations. Their conclusions turned out to be even more surprising.
And after reconstruction,
One of the things we did was to compare children of Chinese origin so we could more or less rule out at least the ethnic aspects of genetic difference who are growing up in Singapore and growing up in Sydney and compare the prevalence of myopia. And it was much, much higher in Singapore than in Sydney. So then we could ask the question, well, what's the difference in their environmental exposures?
There's no longer any doubt. If the origin of the epidemic is not genetic, then we have to be looking at environmental factors. Researchers turned to looking at our way of life. And of course, it was intensive reading and working close up that they turned their attention to. Overall, the experts observed that there is a large proportion of myopics among the student and intellectual community. Through so much reading and observing objects close up, our eyes would seem to struggle with distance vision and thus become myopic.
Nous savons déjà que notre vue peut présenter des défauts. Très souvent, ceci résulte d'une hygiène défectueuse de la vision.
In the 1960s, extensive awareness campaigns were already highlighting the importance of viewing distance for school children.
Établir quelques règles simples permettant d'éviter les causes d'altération de la vue. Regardez cet élève penché sur son cahier. Sa position est anormale. L'élève penché maintient ses yeux à une distance d'environ 20 cm du texte qu'il recopie. Dans ces conditions, sa vue se fatigue énormément.
But in fact, well before that, in the 19th century, ophthalmologist Hermann Cohn wrote about the importance of distance in relation to working and reading. In his 1892 work, The Manual on Hygiene for Eyes, he suggested changing the layout of classrooms so that children would be forced to stay at the right distance from their work. A 120 years later, in a Chinese province, several schools have been experimenting with this preventive method. And elsewhere in Asia, for obvious reasons, researchers have been trying to test the hypothesis of viewing distance at school. Back in Singapore, for the last decade, the government has been financing a number of studies. The aim is to understand the link between working close-up and myopia.
Well, there is a lot of, let's say, distractions indoors itself in this day and age. If you look at it, I think there's more tendency for them to stay inside, watch television, play games.
It's quite common for everyone to wear glasses in my class.
I'm a little bit concerned because none of my immediate family members, like I said, actually wear glasses at a very early age. So she's a little bit different from the rest. So I have no idea what's the cause of that. Probably too much computer or something, reading not in an appropriate environment, something like that.
So the lifestyle of children in Singapore was very different more than 50 years ago compared to now because our economy is growing. So our children are reading and writing, attaining good grades in school. And that's why we see what we call a generational effect in Singapore. A very important effect where in young adults who went through this intensive schooling system, we think that the schooling system in the young adults and the schooling system that the older adults experience was different, and that may be related to near work. So more reading and writing, as we know, causes myopia, but intensive schooling system, the education system, mirrors the increase in myopia rates.
In East Asia, academic success is the major preoccupation, with children spending all their time studying, both during and after school. The results over a number of years have seen Singapore, for example, heading the international school league tables in science, maths, and reading. This obligation to succeed has drawbacks. Myopia is one of the most spectacular of them.
Le travail de près prolongé, donc c'est-à-dire la lecture, la consultation d'écrans comme les smartphones, etc. aujourd'hui, induit au niveau de l'œil des changements, en tout cas au moment de ces efforts, qui sont donc des efforts d'accommodation.
The eye is constantly focusing in order to see properly up close or in the distance. This adjustment is called accommodation. It takes place naturally in the crystalline lens. When an object is close up, the lens contracts, thickens, and adapts. This mechanism takes place thousands of times every day.
La myopie aujourd'hui est expliquée par une augmentation de la longueur de l'œil. Certaines études ont montré que quand les gens lisent longtemps, ou au moment où ils lisent, l'œil s'allonge. Alors il s'allonge peu, il s'allonge de quelques microns. Chez les patients qui ne deviennent pas myopes, l'allongement disparaît probablement, en tout cas est transitoire au moment de la lecture, mais il est possible que chez les myopes, il y ait une tendance à ce que cet allongement, finalement, petit à petit, se produise.
The links between reading, studying, and the onset of myopia have been shown in statistical research. But is this enough to explain the remorseless upsurge in myopia? Some researchers are more than baffled. In Germany, Professor Frank Schiffel has been working on myopia for 25 years. He is world-renowned for his revolutionary experiments on young chicks. His most surprising invention is a system which enables him to evaluate with precision the visual abilities of these small birds.
So, wir messen hier die Fehlsichtigkeit von Hühnern, von jungen Hühnern. Also wir haben hier die Infrarot-Fotorefraktion. Dabei kann man die Fehlsichtigkeit und Kurz- und Weitsichtigkeit von Hühnern oder von jedem anderen Tier auch bestimmen. Was hier passiert ist, dass man infrarotes Licht ins Auge hineinscheint. Das Licht kommt aus dem Auge wieder zurück und man sieht, dass die Pupille dadurch beleuchtet ist. Das Programm findet hier die Pupille und misst dann die Helligkeitsverteilung in der Pupille und ermittelt daraus die Fehlsichtigkeit. Und man sieht auch schön, wenn die Hühner akkommodieren, hier weitsichtig sind, wird die obere Hälfte der Pupille hell. Und man kann dann, wenn man hier die Daten gesammelt hat, die Taste drücken und dann wird hier unten angezeigt, wie kurz- oder weitsichtig das Huhn ist. Das Huhn ist jetzt hier ein bisschen weitsichtig, aber nur 1,5 Dioptrien. Das ist also praktisch normalsichtiges Huhn, so wie es gehört. Ja, also einige grundsätzliche Fragen sind wirklich, einmal, warum macht Lesen wirklich kurzsichtig? Über viele Jahre wurde angenommen, dass wir beim Lesen nicht genau scharf stellen, sondern die Akkommodation, das Nachstellen ein bisschen faul ist. Dann fokussieren wir ein bisschen hinter den Text und dann ist das Bild tatsächlich hinter der Netzhaut und man hat angenommen, dass wir das Auge beim Lesen wachsen lassen. Inzwischen ist diese Hypothese nicht mehr so anerkannt, weil diese faule Akkumulation, die tritt primär auf, wenn man schon kurzsichtig wird und nicht vorher. Und das dürfte eigentlich nicht so rum sein. Auge beim Lesen passiert ja eigentlich nichts, wenn ich die ganze Zeit scharf stelle. Dann ist das Bild ja scharf auf der Netzhaut. Und warum wächst das Auge dann? Irgendwas passiert beim Lesen und der Nacharbeit, was dem Auge sagt, es soll wachsen. Und interessanterweise ist der genaue Zusammenhang bis heute nicht geklärt. Diese Sache ist bis jetzt nicht geklärt und ist eigentlich sehr grundsätzlich. Ja.
By the mid-2000s, the medical community all seemed to agree with this conclusion. Most researchers believe that close-up reading and looking at screens for hours are only part of the answer. Scientists found themselves down a blind alley. Critically, it was at this point that a bombshell was dropped when an American researcher published a new study. Donald Mutti is professor in optometry at the University of Columbus in Ohio. In 1997, he began some highly ambitious research. Over 10 years, he looked into the habits of 4,000 Californian schoolchildren from all backgrounds and origins.
It was important for us to go out to the school, and we got an incredible level of cooperation from the local schools to let us take children out of the school, dilate one of their eyes, go through all these testing, and give them a patch for that eye until the eye stopped being dilated. And it became something fun for them, which was very satisfying to us that they didn't hate us, they didn't run from us. They thought that to come work with us in our van was a really enjoyable, interesting thing to do. When we started, Our main goal was to figure out, is reading bad for children? Is near work bad? That was the prevailing idea. That was the controversy when we started. So we constructed a survey to try and evaluate how children were spending their time. And a lot of the questions were about reading, computer use, television watching. And almost by accident, we decided to add a question. Well, how much time do you spend outside? I hate to think where we'd be if we didn't decide to add that question.
By studying the amount of time the children spent outside, Don Mutti obtained a spectacular and unexpected result. From then on, researchers the world over had something new and promising to work on.
What we were finding was that near work, all of these ideas that were bad, don't sit so close to the TV, don't watch TV, don't use that computer so much, video games are bad. All those ideas about what was causing nearsightedness and myopia didn't come true in our study, but this time outdoors was something that consistently showed a reduced risk. More time outdoors made for a reduced risk for the onset of nearsightedness.
A second bombshell landed. While Don Mutti was carrying out his study, Australian research carried out by Ian Morgan and his colleague Catherine Rose came up with a similar conclusion. The level of education was indeed important, but it wasn't enough. It was the time the children spent outdoors which turned out to be the overriding factor.
Australia is a remarkable outlier because we have a very highly educated population by world standards, well up in the top 10 to 20 countries in the world, but we have ridiculously low levels of myopia. And when you start thinking about what that might mean, one of the ideas we came up with was the idea that maybe it was the very outdoors-oriented lifestyles of Australians that was actually important.
What we found was the chances that a child would become myopic in our study went from about 60% if a child had two myopic parents and spent very little time outdoors. You could still have two myopic parents, but if you spent 2 hours a day each day, 14 hours a week, your chances of becoming myopic were reduced to about 20%. So that's a 3 times reduction in the chances of a child becoming myopic by a simple, ordinary, natural activity of 2 hours a day in our study would be our recommendation for what was really effective that way.
So this was a decisive turning point in the fight against myopia. Don Mutti had just identified the first cause of the myopia epidemic, the amount of time spent outdoors. It's all down to the early years. Even if children read a great deal or play for hours on video games, the harmful effects on nearsightedness are outweighed by time spent outdoors. On the face of it, it's a simplistic explanation, and so the researchers had to go much further to understand exactly why being outdoors helps prevent myopia. Is it the fresh air, the physical exercise, or the fact of being able to see longer distances, or even being exposed to bright sunlight, which is beneficial? Professor Frank Scheffel and his small chicks in the Tübingen laboratory in Germany were able to get to the bottom of the mystery.
Wir hatten keine Hypothese, weil in den Veröffentlichungen von Don Mutti und Kathy Rose und Ian Morgan später stand ja zunächst auch nur, dass die draußen, keiner wusste, warum jetzt das hilfreich gegen Kurzsichtigkeit ist. Wir haben einfach geguckt, ob diese Experimente oder Untersuchungen bei Kindern, bei Hühnern wiederholbar sind in der Form, ja. So,
Frank Scheffel was able to go further, thanks to his ingenious device for evaluating myopia in chicks.
So what we have now here is a chicken eye again, I hope, sometime.
He decided to fit them with a semi-opaque lens. This simple procedure brought about myopia similar to that in humans. After several days spent entirely indoors, all the chicks fitted with these lenses became short-sighted.
Haben wir beschlossen, dass wir mal die Hühner in hellem Licht auf dem Balkon untersuchen. Also wir haben einfach die Hühner auf den Balkon gestellt. Unser letztes Forschungsgebäude hatte einen schönen Balkon. Dann haben wir gefunden, dass in dem hellen Licht draußen die Hühner nur etwa halb so kurzsichtig wurden.
Frank Scherfel suspected that it was daylight which was slowing down the onset of myopia. To prove the theory, he decided to bring the chicks back inside and place them under a very strong artificial light.
Helle Lampen gekauft, wie man sie normal zum Filme drehen verwendet, und haben die Hühner im Labor dann mit 15.000 Lux behandelt. Das ist also nicht gnadenlos hell, es ist so hell wie an einem bewölkten Sommertag draußen, ist also nicht gefährlich oder so. Und auch da sind die Hühner nur halb so kurzsichtig geworden.
This was a giant breakthrough thanks to Frank Scherfel's tiny chicks. Exposition to daylight is what protects our eyesight. And inversely, being deprived of that light leads to the deformation of the eyes and to myopia.
Once we knew that light was important, it became then important to measure what were the sorts of light intensities that would be protective. You almost never see light intensities of over 1,000 lux inside. A bright day in can be looking at 150,000 to 200,000 lux. The thing we're unsure about is just how high you need to go in order to get protection. This hasn't really been properly quantified in human populations yet. We know outside is the trick, but it might be 10,000 lux we need to get to or more. It could be a bit lower than that.
In order to measure the minimum degree of luminosity necessary to protect the eyes from myopia, the researchers redoubled their efforts. The quantity of light perceived by our eyes in everyday life can be measured in all sorts of ways. The scientists searched for the most precise measures. Over a period of months in Canton, Ian Morgan and his ophthalmologist colleague Wei Zhonglan have been trying out a new system.
Eye growth, so that seemed natural. So we started off with something like this, a simple light meter measuring light out intensity. It's very basic, and it's not easy to use in research.
Exactly. So that's why we developed this device. It's because it can very easily attach into the spectacles because it is exactly located in the same angle with your eyes. So it can exactly measure the light absorbed by your eyes.
To fully understand the different intensities of brightness to which our eyes are exposed, we took part in an experiment with this sensor. This small device doesn't just calculate intensity in number of lux, it also detects the light's quality, spectrum, and wavelengths. It was Isaac Newton who discovered that the sun's white light was made up of a mix of 6 chromatic colours that we can see in rainbows. These rays of colour behave like waves, and the waves are of varying lengths depending on the colour and affect the eyes in different ways, positively or negatively. And so today, several studies are focusing on the wavelengths of the colour blue.
Blue is more of a predominant wavelength outdoors compared to indoors, and certainly more intense. So there are photoreceptors that are sensitive to blue. There are also photoreceptors that are sensitive to red. So what we do is we do comparisons between pupil responses to red and pupil responses to blue. All right, so just position your head there comfortably, and let's see what we see here. When the colors change, if you count to 1 or 2 before you blink.
According to Don Mutti, blue causes a certain natural chemical reaction in the eye, which protects us from myopia.
Light stimulates the neuromodulator called dopamine. That's what I think we're seeing in these pupil responses. The pupil is constricting more actively because of this release of dopamine. That dopamine release is making everything more sensitive, more responsive to blue, more responsive to being outside.
Dopamine is a molecule produced not only in the brain, but also in the retina. It's the substance that controls the eye's growth. When the eye is exposed to a large amount of blue light, the retina is stimulated, dopamine is released, and maintains the pupil's round shape. Conversely, when there is very little light, more reddish in color, the levels of dopamine decrease, causing the eye to elongate.
It's been found that dopamine is something that lowers the chances that a child will become myopic. So the more time you spend outside, the more dopamine you release, and the more dopamine you release, the more slowing of myopia that you get, which is beneficial to the child.
So, dopamine and blue light would seem to explain why there are so many short-sighted people in the world. Our way of life means that we spend so much more time indoors, in particular studying, and this interferes with the development of eyesight in childhood. And once myopia has set in, it's irreversible.
There's still a mystery out there that more time outdoors doesn't seem to change how fast myopia progresses, how many prescription changes a child will have. So there's still a great challenge. All of this time outdoors stuff is of almost no use to a child once he or she becomes nearsighted.
The battleground has now moved elsewhere. How to treat myopia once it's diagnosed? How to help the millions of short-sighted people around the world? Once the pupil has become too deformed, medicine has few answers. Those with myopia are forced to wear glasses or contact lenses. For less serious cases, surgery is the best treatment available. For Yael, today is a big day. In a few hours, her myopia will be cured for good, and she'll be able to regain normal sight.
Ici
E-D-F-O-R.
Très bien. Si je fais ça. Ici
N-D-Z-N-F.
Oui.
Bonjour.
Bonjour.
Matinelle, venez, asseyez-vous.
Merci.
Voilà, posez votre manteau. Bien, alors, qu'est-ce qui vous conduit à venir nous consulter aujourd'hui?
Mon cousin.
Votre cousin?
Vous l'avez opéré il y a maintenant 2 ans,
oui.
Et il est très très content du résultat. Donc j'ai pas une myopie très forte,
oui.
mais je porte les lunettes constamment et ça me gêne. J'aurais bien... et les lentilles, je les supporte pas véritablement.
Alors, l'œil myope, c'est essentiellement un œil qui est un peu plus long qu'il ne devrait être. Le but de la chirurgie, c'est pas de raccourcir l'œil, c'est de changer la courbure de la cornée pour que les rayons qui traversent l'œil aillent à nouveau focaliser dans le plan de la rétine. Donc on fait un réglage finalement grâce au laser de la courbure de la cornée pour lui donner la bonne puissance optique de manière à corriger, à compenser votre myopie.
For one of the most common techniques, the procedure takes place in 2 stages. Initially, a first laser shaves a thin layer of the cornea, known as the corneal flap, which is then folded back. A second laser then works on sculpting the cornea into a predetermined shape according to the characteristics of the patient's eye.
Une fois que le changement de forme imprimé à la cornée est calculé, le laser sait que chaque impact enlève un volume de matière prédéfini. Et tel un sculpteur qui, à chaque coup de burin, enlèverait la même quantité de matériaux ou de plâtre, le laser va déterminer combien de tirs et où mettre ces tirs pour changer la courbure de la cornée.
Nowadays, this is a routine operation and complications are rare. Extensive tests are carried out beforehand to check on the patient's health profile so as to reduce the risks. The operation is quick and simple, but expensive and is not reimbursed by the health service. It costs around 2,000 to 3,000 euros for both eyes. This is the price to pay to be free from glasses and contact lenses forever. Just 8 short seconds is all it takes to get rid of myopia and restore normal sight.
Ouvrez grand. Ça va?
Ouais.
Une myope de moins. Est-ce que vous voyez l'heure là?
Ouais.
Quelle heure
1h32.
1h32, exactement.
Super.
Ouais. Voilà, donc à 1h32 aujourd'hui, vous n'étiez plus myope.
Voilà.
Et puis je vous revois tout à l'heure pour le contrôle. Hein.
D'accord, très
voilà,
bien.
venez, on va aller en salle d'attente pour se reposer un peu.
Yet this surgery is not a miracle treatment.
La chirurgie ne peut malheureusement pas être l'arme absolue contre les bataillons de myopes à venir. Certains myopes ont très peur de se faire opérer et c'est peut-être le frein majeur pour des raisons que l'on peut comprendre. Mais pour des raisons aussi de limites physiques, en tout cas avec les concepts actuels, on ne pourra pas corriger tous les myopes, en particulier les myopes forts, pour qui il faudrait que la cornée soit beaucoup plus épaisse, de manière à leur permettre d'avoir cette correction dans le plan cornéen, ce qui n'est pas possible chez eux. Posez le menton et d'appuyer le front.
What's more, the operation is too expensive to be accessible to all. Many people with myopia would not be able to afford it. The ideal solution, in fact, would be prescribed medicine, administered from childhood as soon as myopia is diagnosed, which is capable of slowing down the condition or even stopping it. This dream could well become a reality. In Singapore, a new product has been tested by Professor Donald Tan's team.
About 85% of all our children are myopic. So we felt responsible to the Singapore public. We started very early to look at potential treatments to prevent or retard the progression of myopia. And we had been looking at different types of eye drops which could have an effect on eye growth. Atropine is an old drug. In fact, it is a cardiac drug which can be made into eye drops, and eye doctors were using it to dilate the pupil.
Atropine is derived from belladonna, or deadly nightshade, a well-known plant with a notorious reputation. Nicknamed the devil's cherry, it became famous during the Renaissance as both a poison and a medicinal plant. The word belladonna originated from Italian, named after the beautiful aristocrats who used the plant as a beauty accessory. Applying several drops of a mixture based on belladonna into their eyes made their pupils dilate, thus giving them the famous doe-eyed seductive look. Atropine drops are regularly used by ophthalmologists to stop the eye blinking and to dilate the pupil when testing eyesight. But today, this substance could have a more important role to play.
Well, atropine affects the growth of the eye, but how, we don't really know yet. What we do know is that we can slow down the elongation of the eye. Myopia occurs because the eyeball grows too long, and we're now able to show that atropine can prevent that elongation by up to about 50 or 60%.
Having established this principle, the next step was to put into practice and perfect the atropine-based treatment. In 1999, Donald Tan and his colleagues started testing on a large scale on hundreds of school children, but they had mixed results.
This study showed that atropine 1% is extremely effective in controlling myopia progression. But we realized that whilst atropine is effective, it has got some side effects because it can dilate the pupil, which means the children may have more glare when they go out in the sun. Some of them may have some difficulty reading, focusing for near. So obviously you cannot have children who can't read. And therefore, we decided to do a second trial in which we went down to 1/100th the concentration, a very, very small amount, and that was 0.01%. And it worked. It was fascinating because for the first 2 years, when the children were using the eye drops, we realized that the lowest dose, which we hadn't expected to work, also has almost no side effects. And we're treating hundreds and hundreds of children now with our 0.01% atropine, which we call myopine. So myopine is this low-dose atropine which we have made.
Myopine would seem to be the first truly effective medicine capable of slowing down myopia once the condition has developed. But it's only been fully developed recently and is only authorized in Singapore and Japan at the present time. Even if promising treatments come on the scene, none of them could significantly stem the tidal wave that has hit Asia and soon the rest of the world. But some countries are pulling out all the stops. They're targeting prevention on a grand scale applicable across the board. Taiwan is the first country to have embraced the recent scientific discoveries based around the role of luminosity. We meet up again with Professor Ian Morgan, who's been invited to Taiwan. This is a moment of truth for him. He's going to be able to see for himself if his ideas have had any impact in the fight against myopia. He's been invited by Pei-Chan Wu. This professor of ophthalmology has put in place a series of preventive measures inspired by Ian Morgan's work.
So in Taiwan, they can accept that in primary school, do not too much homework.
Yeah.
Play smarter and play very well. And today was a very...
And play outside.
Yeah, play outside.
With more than 2,500,000 inhabitants, Kaohsiung is the second largest city in Taiwan. In this medical school, nearly 90% of the students are myopic. In Taiwan, just like elsewhere, reducing the percentage of myopia has become an absolute priority. The authorities have given Professor Wu carte blanche to make this happen.
This picture showing that it is going high every year, and to the 2010, we do nothing very successful, especially for the myopia. Yeah. Then at that time, I cited the most updated evidence from Professor Morgan showing that outdoor activity is most important. So I strongly suggest to implement the outdoor activity to the school children vision care program. Till now is 5 years. Then we can see the trend is inversed and then continue to go down.
It makes a scientist really happy to see this, and so rapidly. Like, we published our paper in 2008, Don Mutti published in 2007. Within less than 10 years, we're seeing the positive effects come through. So that's really fantastic.
A spectacular change is underway in Taiwan. The rate of myopia in school children has been dropping by 10% every year since 2010. Professor Wu has achieved these results through a radical transformation in a number of schools. By imposing a minimum of 80 minutes of outdoor recreation a day, the double of the average amount in Europe. Outdoor activities are systematically prioritized. In this pilot school, the natural science lessons now take place in the school's garden. Tablets and digital screens are no longer a threat, especially if they're being used outdoors. Classrooms have also been redesigned.
其实那时候我们也在思考，怎么样才能够真的让孩子的近视降低。所以基本的在学校环境上面，教室内的照明照度一定都要够。所以每年开始，在换了新教室之后，我们就会先做这样的测量，要学校的教室照度要在350流明以上，那黑板的要在500，这个都是很基本的。
你的右手，右脚，哪一只？在哪里？你的左脚。
Professor Morgan can see the tangible proof of the fruits of the research he started nearly 20 years ago.
I certainly feel that there's a kind of crusade against myopia, that once we knew how we could prevent myopia, then it's important to translate that into practical implementation. And so, I've been travelling a lot in order to make sure that this happens. And then you get people like Professor Wu who take it up very enthusiastically and make it national policy in Taiwan. And we've seen from some of the results that it is really starting to work.
Could the success achieved in Taiwan be transferable to the rest of the world? In the last 10 years, scientists have been able to prove that simple solutions do exist. Spending time outside, going for walks and taking advantage of the sunlight. This is basic and free health prevention. The fight against myopia is an issue which involves everyone: ophthalmologists, teachers, politicians, and parents. And for once, the solution is easy. Go outside and get some sun on your face.